is several meters high or several feet high, meaning the land rose and sunk at the same time. So if you were standing down inside of this crack or this fissure, you would basically disappear. You're looking at about 16 to 20 feet, possibly even more. You can see the size of that man standing there in the video. He looks to be approximately 6 feet tall. So if you place him down inside of that crack, this crack is actually over his head. And this fissure just goes on and on and on. Now, we're going to go ahead and move to another video clip. Now, again, this goes into more of the scientific aspect of their research and their findings. Now, this portion of video is what really caught my eye. Ladies and gentlemen, what you're looking at here, this was once a beach, a regular beach with a little coastal roadway that went all along the coastline. This piece of land that you see right here actually was the ocean bottom. This piece of land was not there the day before this earthquake. It was not there. Now, it is a permanent land mass in the middle of this beach. Amazing. Amazing at the devastation and the changing of the land that an earthquake can produce. And that's why I am so worried about the entire state of California. If something like this would occur under any of the major cities in the state of California, it would be total mass devastation. The USGS has come out last month warning of a 7.4 or greater magnitude earthquake to hit California. So what is to say that something like this occurs in the city of Los Angeles or San Francisco? We all saw the devastation back in, I believe it was Oakland, California, and San Francisco many, many years ago. That was just absolutely total devastation. And one of the biggest problems is underground gas lines. Once that type of earthquake hits, the gas lines rupture, they create fires, and then a totally different type of hazard. But let's take a few minutes and let's listen about what happened on this beach, because now the ocean bottom rose up and is now a permanent fixture on this beach. Let's listen.
Standing here in the Papatea Fault, a few kilometres south of the Clarence River Bridge on the Kaikoura coast. Looking here at actually the fault plane, the plane of movement along the fault itself, where this side here has moved up by about 1.5 metres, and we can see the gravels here and the gravels on that side. But what's really interesting is that we can see lines of movement here on this fault plane which are moving down a little bit in this fashion. And that means we can see, it looks impressive that we're standing here 1.5 metres high, but in fact most of the movement has been along a plane something like this. So this side here has moved forwards by many, many metres. These fault scarps form very, very quickly. And we know from earthquake physics that probably this fault scarp ruptured across here at a speed of about 3 kilometres a second. So this has uplifted a very large area of new reef here, and the locals here describe not the earthquake noise, but the noise of water running off the top of this uplifted platform here. They said that the noise was just horrendous. And on the downthrown side of the fault, it's actually still even come up by about 1.5 metres. On the other side, there's as much as 6 metres of uplift.
So, ladies and gentlemen, if you take a look